Now that we have got the SRA reads, now that our raw read section has been done, just like here, sorry, I gotta open that laser pointer. Yep. If the laser pointer is pointing at the raw reads, you can see that raw read section has been done. We have retrieved the raw reads. Now, after retrieving that reads, I have trimmed that read into shorter sections. Shorter section because I only need two reads to just show you how to get all this done. And for your analysis, you got your pipeline. You can just use the pipeline to get all your sequencing data and variant extraction done. So now we are moving on to the quality control, how to check the quality control and quality trimming process. So basically what quality control is. So FastQC is a tool that do some quality control checking and checks on raw sequence data coming from the high throughput sequencing pipelines. So it provides a modular set of analysis which can give us a quick impression of whether our data has any kind of problem. Like it can be used for the further analysis or it cannot be used for the further analysis. So the main functions that FastQC tool do is it import any kind of data. Like you can apply FastQC on SAM data, BAM data, or FastQ file. So it just provide a quick overview to tell that which area our area has problem, our sequence area has problem. So summary and graphs will be created to easily access and then we can export the results. So what FastQC basically do, it will give us the overview. So something like this, there will be this quality of data that will be generated and then this quality of data that we get from trimming this data. So trimming is also a next procedure. So first we need to use these. So we are going to copy these commands and paste it in our notepad. Then we have to update the system. So let's just update our system. Let's see if there are any updates that are available. I'm gonna type my password and then see. Yes, there are updates that are available to my system. It's checking if 6 packages have updates, 7 packages have updates. So while the system is updating, let me tell you about the FastQC tool. So you can install the FastQC by using this command. It is available in the APT system of our Linux and Unix terminals. So I already have installed these tools. Like I have done a lot of analysis on this computer as well and on the other machines as well. So in this terminal, all the tools are available. So let's just see if FastQC is available. I'm just gonna type FastQC and see if there are any kind of FastQC installed. And yes, in this folder I got the FastQC. So how to apply FastQC? So let's just type FastQC file.fastq and then create a output and then just don't do anything, just apply the FastQC on file.fastq because we contain the file.fastq data, and then there were the result that will be generated. Like file.fastq was our fastq file. So file.fastq.html will be the result file of our SRA of our data, SRA data. Yes. Yep. Here it is. So it's showing the file name of file.fastq. It is encoded by the Sanger Illumina sequencing and the total number of sequences that were present because I trimmed out all the other sequences. So 2 sequences were present, the sequence length was 72 and the GC content was not enough. But here you can see which things are enough and not enough. So basic stat is good. Per base sequence quality is also good. Per base sequence quality score is not that good, but it's in the danger zone. So per base sequence content is good. All this stuff is doesn't really matter because per base sequence content and GC content and N base content will be completed when we got a lot of file. Like here if we got 7,000 number of sequences, 8,000 number of sequences, then this wouldn't be a problem. This would be a problem. Per base sequence quality is problem always, because our data lies down in somewhere in middle zone, so we don't have that kind of problem right now. So for example, if we got this kind of data, let me just show you. There is bad quality data. How to trim these all out and get the good quality ones? So what is quality trimming? So rate trimming is a process which aims to improve the low quality, which aims to remove the low quality portion while preserving the longest high quality of NGS read. Trimming is shown to increase the quality and reliability of the analysis, which concurrent gains in performance. Which tool we are using? Trimomatic is also a good tool to use for. PoreShop is also a good tool. So PoreShop is a tool for removing the adapters. Adapters on the end of the reads are trimmed off, and when a read has adapter in its middle, it is then chopped into separate read. So PoreShop performs through the alignment to effectively find adapters even at low sequence identity. So let's just see if our data contain any kind of adapters. There are only two sequences, there won't be any uh, there won't be any adapter that were attached to it, but for the sake of this course, I'm just gonna apply the PoreShop tool to our file.fastq and get the result. So let's just see if there are here file.fastq is present and see PoreShop is available in this directory. PoreShop, yes, we can get the PoreShop here and then apply the PoreShop tool to our file.fastq. Sorry, PoreShop file.fastq and then generate the output of trimmed.fastq. Yes, it is saying that I haven't enabled the input. Sorry for that. Yes, here you can see again. I'm gonna perform this, and here you can see there are loading the reads. There were two reads that were loaded, and two reads don't have any kind of adapter set. But the reads were divided into several barcodes, forward and reverse, and no adapter were found. Output was unchanged. There wasn't any change in our output. So basically what quality trimming does. So here you can see I have the bad quality data. So by using the PoreShop, I can get the good quality just like this. So what it does, it trim out the danger. Here is the danger zone. So it trim out the danger zone and the middle zone data into good quality scores data. For example, here you can see that we only got the good quality scores, only the quality scores that were above threshold, like the set threshold for the PoreShop tool is 5, and there are no adapters in these sequences. These are the pure sequencing data that we can get. So that was it for the quality trimming process. So we know that how to check our quality, how to check and after checking the quality, how to trim that quality. Now if you are working on your main NGS data, first you gotta check the quality of data. After checking the quality, you then have to check if the quality is good. If the quality isn't that good, then apply the trimming process on it. After applying the trimming process, then again check for the quality. If that quality has been improved, if the quality of data has been improved, then your quality checking and quality trimming process was successful. So that was it for this lecture. In the next lecture, we will be moving to the reference genome alignment and alignment against the reference genome. So after that, we will be moving on to the reference annotation as well, and then we will be moving to the depth and coverage computing. So that was it for this lecture, I think so.